up at the night sky, what do you see? Pinpricks of light scattered across an inky blackness. For millennia, humanity has gazed upon this vast canvas, asking the most fundamental questions. Where did all of this come from? How did it begin, and what is our place within this boundless expanse? These aren't just poetic musings. They are the very questions that drive the science of cosmology, the study of the origin, evolution, and ultimate fate of the universe. It's a journey from the infinitely small to the unimaginably vast, from the earliest moments of time to the farthest reaches of space. And in this series, Cosmic Chronicles, we embark on that incredible journey together. Welcome to Cosmic Chronicles, where we explore the universe and the science that unlocks its secrets. Today, we lay the groundwork by defining our field of study, cosmology. At its heart, cosmology is an attempt to understand the universe as a whole. It's not just about individual stars or planets. That's astronomy. Cosmology seeks the grand narrative, the overarching principles that govern everything. Think of it as the ultimate detective story, where scientists piece together clues from light, gravity, and exotic particles to reconstruct billions of years of cosmic history. This isn't just a pursuit for scientists in labs. It's a fundamental aspect of self-development. Understanding the universe expands our perspective, challenges our assumptions, and offers a profound sense of awe and connection to something far greater than ourselves. It puts our daily lives into a humbling, yet empowering, context. To understand our place in the universe, we first need to pinpoint our cosmic address, starting from the familiar and expanding outwards. We begin, of course, on Earth, a vibrant blue marble orbiting our sun. Our sun is a star, just one of hundreds of billions in our galaxy. Together, the sun, its planets, their moons, asteroids, and comets form our solar system. We reside in the inner, rocky part of this system, alongside Mercury, Venus, and Mars, while the gas giants like Jupiter and Saturn dominate the outer reaches. Our solar system is located within the Orion arm of the Milky Way galaxy. Imagine the Milky Way as a gigantic spiral city of stars, roughly 100,000 light-years across. Our sun is just one relatively average star orbiting the galactic center, taking about 230 million years to complete one revolution. If our solar system were the size of a coin, the Milky Way would be the size of North America. But the Milky Way isn't alone. It's part of a collection of galaxies called the Local Group. This group includes our major neighbor, the Andromeda Galaxy, which is actually on a collision course with the Milky Way. Though don't worry, that's billions of years away. This local group, in turn, is just a small cluster within a much larger structure called the Virgo Supercluster. And even superclusters are just threads in the vast cosmic web. This layering of structures helps us grasp the sheer scale we're dealing with. Now, let's confront the truly mind-boggling concept, the observable universe. This isn't the entire universe, because the universe is so vast and light travels at a finite speed. We can only see as far as light has had time to travel to us since the Big Bang. So when we look at a galaxy billions of light years away, we're not seeing it as it is now, but as it was billions of years ago. It's a cosmic time machine. The light from the most distant objects we can detect has been traveling for approximately 13.8 billion years, which brings us to the edge of the observable universe and the beginning of time as we understand it. This leads us to the concept of the expanding universe. Edwin Hubble's observations in the early 20th century using the redshift of light from distant galaxies showed that galaxies are not just moving, but they are moving away from us, and the farther away they are, the faster they recede. This isn't because we're at the center of an explosion. It's because space itself is expanding, stretching the fabric of the universe and carrying galaxies along with it. Imagine blowing up a balloon with dots on its surface. As the balloon inflates, the dots move farther apart from each other, but no dot is at the center of the expansion. This expansion is a cornerstone of modern cosmology, and a key piece of evidence for what we call the Big Bang Theory. If the universe is expanding, then logically, If we rewind time, it must have been smaller in the past. Rewind far enough, and all the matter and energy of the universe would have been compressed into an incredibly hot, dense state, a singularity. This moment, about 13.8 billion years ago, is what we call the Big Bang. Now, it's crucial to understand the Big Bang wasn't an explosion in space, but rather an expansion of space itself. There was no outside for it to explode into. Here's a simplified timeline of this cosmic genesis. Fraction of a second, the universe undergoes an incredibly rapid expansion called inflation, stretching space by unimaginable factors. First few minutes, as the universe cools, fundamental particles like quarks and electrons form. Then as temperatures drop further, they combine to form protons and neutrons. 380,000 years later, the universe cools enough for electrons to combine with protons and neutrons to form the first stable atoms, primarily hydrogen and helium. At this point, the universe becomes transparent to light, and this ancient light, stretched by expansion, is what we detect today as the cosmic microwave background CMB radiation, the afterglow of the Big Bang. It's one of the strongest pieces of evidence supporting the theory. Hundreds of millions of years later, gravity, ever present, begins to pull these early atoms together, forming the first stars and eventually the first galaxies. These early stars were massive and short-lived, forging heavier elements in their cores, which were then scattered into space by supernova explosions. These heavier elements became the building blocks for subsequent generations of stars, planets, and us. So our journey from Earth outwards reveals an astonishing reality. We are part of a vast, expanding, and incredibly ancient cosmos. From the subatomic particles born in the Big Bang to the immense structures of galaxy superclusters, every single piece of our existence is interwoven with this cosmic story. The atoms that make up your body, the carbon, the oxygen, the iron, were forged in the heart of ancient stars that lived and died billions of years ago. We are, quite literally, stardust. Our place in the universe is both infinitesimally small in scale, yet incredibly significant in the fact that we are the conscious beings capable of pondering its very existence. Understanding cosmology isn't just about scientific facts. It's about gaining a deeper appreciation for the profound interconnectedness of everything and our unique, precious role as observers of this grand cosmic ballet. What cosmic mystery do you find most fascinating? Share your thoughts in the comments below. This was just the first step into the Cosmic Chronicles. In our next episode, we'll zoom in closer to home, exploring L1.2, the solar system, our cosmic neighborhood, delving into the planets, moons, and other wonders right here in our backyard. To continue your journey through the universe and deepen your understanding, subscribe to the Knowledge Compass and activate the notification bell. Share this video with fellow stargazers and curious minds. Thank you for exploring the cosmos with us.